Hi guys. So I hope all of you are doing well. Um, Staying inside, getting outside. Um, we are officially done with Algebra 1 curriculum. Congrats, you made it through. So for the last 2 weeks of school, we're going to be basically reviewing some topics for next year. So some basic geometry topics so that you guys can get ready for Miss Geist next year. So we're going to start off with 2D figures, just a review of like shapes, and then we're going to go into Pythagorean theorem and maybe do a little bit of, I don't remember what else. But, so we're going to start off with 2D figures today. So basically, we're only going to go over very mild cases. You've seen all this before probably in middle school, but we're going to start off with rectangles and squares. So I have this here as our little cheat sheet. So we have rectangles. Some basic things that we know about rectangles is that it has 4 right angles. Right angles are 90-degree angles. It has 2 sets of parallel lines opposite from each other. So the top and bottom, they're parallel to each other, parallel meaning that they never are going to intersect. And also then these up and down lines here on these sides, those are also parallel lines. Now, because we have 2 sets of parallel lines, that is actually what creates the 4 right angles, right? And these boxes in the corners there, that is going to tell us that they are 90-degree angles. Anytime you see a box like that, that's going to immediately tell you that these are right angles. And since we have 2 sets of parallel lines, when they intersect, they create 90-degree angles. So we have 4 sets of right angles. Lastly, we have 2 pairs of congruent lines. Congruent means that they are equal or the same. So this dash mark on top and bottom, one dash mark means that those 2 lines are congruent to each other. And then you see the other ones, there's 2 dash lines. Those means that those 2 lines are congruent to each other, but not congruent to the other set of congruent lines, right? So in a rectangle, we all know that they don't have 4 congruent lines like in a square. So squares and rectangles, very similar, except for one thing that's different. Squares have 4 congruent lines. So you can see on the square here that there are 4 dashes on all the sides, means that those 4 sides are all congruent. And then we also have 4 right angles and 2 sets of parallel lines. So we still have the up and down parallel lines are parallel to each other, and then the horizontal lines are also parallel line to each other. So those are rectangles and squares. And then we also are going to go over triangles. So triangles are a little bit different, and triangles are very important in geometry. So to start off, we can categorize triangles in 2 different ways. We can categorize them based on their side, and we can categorize them based on their angles. So for sides, we can categorize into 3 different things: equilateral, isosceles, and scalene. So let's go through that a little bit slower. Equilateral, if you look at the word itself, you see the word equal in it. So equal means that they're all going to be the same. So if I draw an example of my best example of an equilateral triangle, I'm going to give those dash marks that states that all those 3 sides are going to be equal to each other. So that would be an example of an equilateral triangle. An isosceles triangle, a little bit more difficult. You can't really see a context clue in the word, but an isosceles triangle means that 2 of the 3 sides are equal to each other. So we draw a triangle and we put dash marks on any 2. It doesn't really matter for an example, but any 2 sides, those are going to be equal to each other. So we have all sides equal, two sides equal, and you can guess it maybe that a scalene triangle is going to be an example of a triangle with no sides equal to each other. So all three of the sides of a triangle are all, that was a bad example, are going to be opposite sides. So 1 dash, 2 dash, and 3 dashes. So that is how we are going to write a scalene triangle with 1 dash on one side, 2 dashes on the other, and 3 dashes on the last one, signifying that all three of these sides are not equal to each other. So this is no sides equal. Lastly, the other way we can categorize triangles is by their angle. So we have also three different types of triangles for that way. We have acute, right, and obtuse. So to start with an acute triangle is a triangle that has the angle measurement, the interior angle, so interior meaning interior. The interior angles, none of them are greater than 90 degrees. So back to that 90-degree angle, that's kind of our like baseline. So you'll see in an acute triangle, try to draw that well, that we might have a triangle. It looks kind of like this, where we could have maybe one angle be 60 degrees, one be 61, and that last angle be 59 degrees. Now, I didn't quite make up those numbers off the top of my head. Those are important because if you add up those numbers, 61, 60, and 59, they are going to equal 180 degrees. And that number is super, super, super important with triangles because all triangles have a sum of interior angles of 180 degrees. So in an acute triangle, if it's all less than 60 degrees, then we have to have, well, it could also be 60 degrees, so 60 degrees or less, I should say. Less than 90 degrees. There you go. Less than 90 degrees, then we can have 60, 61, 59. They have to add up to 180 degrees. A right triangle, which is going to be important when we go into Pythagorean theorem. Back to that, remember from the square and rectangle, that box tells us that it is going to be a right angle. So a right triangle means it has a right angle in it. Right angles are 90 degrees. So if that box means that it's 90 degrees, a right triangle means it contains a 90-degree angle. So we could have 90 degrees, we could have, the other two could be 45 and 45. That gives us a sum of 180 degrees. That works out as an example. And lastly, we have something called an obtuse angle, which looks kind of like this. It could look like this. And you notice that this bottom angle here is going to be greater than 90 degrees. So acute means it's less than, I wrote 60. This is why I was talking bad. There we go. Less than 90. A right triangle contains a 90 degree, and obtuse are greater than 90 degrees. So let's give an example. You can make this one 120 degrees. This one could be 35 degrees, and this could be 25 degrees. Now, I kind of made up these numbers. They do have to add to 180 degrees, but this is not the end-all be-all example, right? This is just one example of what these angles could be. It could be an obtuse angle and be 91 degrees, could be the greatest angle, right? So just because it's 91 degrees, it's still greater than 90 degrees. So it has to be an obtuse angle. So that is basically an overview of basic 2D figures. We have our rectangles, our squares, and most importantly, our triangles. So we will continue these videos moving forward. Gonna start shying away from Delta Math a little bit. I know you guys like Delta Math. Miss Geist uses Desmos a lot. I'm not sure if we're going to be using Desmos or not, but I hope you guys are doing well. Go outside if you can. Stay hydrated. I just got one of those color-changing Starbucks cups today, and I'm pretty excited about it, so that's how I'm staying hydrated. And of course, as you guys know, I have my Delta Math water bottle still with me. So, have a good day, and I will see you next time.